friends. Today we're going to be talking about solving logarithms and exponential equations. Okay, so a couple of things that I want to review real quick is that common log has a base of 10 and natural log has a base of e. Now this is when we don't have the base written. Okay, so if I just saw log of 3, I would assume that the base is 10. And if we had like natural log of 5, I would assume that the base is e. So again, 10 and e. Okay. We assume these things such that we can correctly solve, and we can solve this nicely. Okay. So let's continue on. So I gave you a couple of steps just to kind of help you think it through. So our first step is to switch to log or exponential. We're going to simplify next and then solve for x. Okay, this is just when logs will equal a number or exponentials equal a number. Okay, if you have something that looks different, you're going to do a different 3 steps. Okay, so looking at our first example here, we have log base 3 of 7x plus 6. Okay, so what I'm noticing right now is that, these should have parentheses on them. Okay, real quick. Parentheses. All right. So what we should do first is that we are going to switch to log or exponential. Now remember from the previous lesson, we've talked about converting from exponential to log and log to exponential. Okay, if you have log base b of a equals x, then if I want to go to exponential, it's going to be b to the x power equals a. So now we're going to apply that to our example. So the log, our first step, we're going to convert. So the little 3 will now become big, just like the b over here. So 3, and then the 3 on the other side is going to switch with the 7x plus 6 and become the exponent of the other 3. Then we're going to set it equal to the 7x plus 6. Okay, that is always going to be step 1 for us. Step 2 is going to be simplify. So we're going to simplify the 3 to the 3rd power. When you simplify 3 to the 3rd, it's going to be 27 equals 7x plus 6. So then we're on to our last step, and that is to solve for x. Okay, solving for x, we are going to subtract 6 from both sides, and we're going to get 21 equals 7x. And then we're going to divide both sides by 7, and we'll get a nice x equals 3. Okay, and that's it. That's how you solve these basic ones. Okay, I'll do one more example with you. Okay. So now we have log of 11x minus 21 equals 2. I remember the parentheses this time. Okay, so now I notice that immediately that we don't have the little base number here. Well, because this is log, we are going to have base 10 here, okay? So sometimes what I like to do is I like to rewrite it real quick so that I can remember that it's log base 10, okay? Now I'm going to follow through with our steps. So first step is to switch to the other format. So I'm going to switch it to exponential. Okay, so the 10 becomes big, all right? And then the 2 and the 11x minus 21 are going to switch sides, but 2 is going to be the exponent of 10. And then equals 11x minus 21. Second step is to simplify. So we're going to simplify the 10 squared. So we're going to get 10 squared is 100 equals 11x minus 21. Then we're going to add 21 to both sides because our last step is going to be solving for x. So that's going to give us 121 equals 11x. And then I hope you know this, but 121 divided by 11 is going to be a nice 11. Okay. Cool. All right. So remember that this one is going to have parentheses as well. So fix your worksheet real quick and make sure it has parentheses. Okay, I made a mistake, my bad. Now I want you to pause the video here and see if you can solve number 3. Okay? All right, here's my work. Okay, so you should have switched first. So 4 to the 4th equals 3x plus 4. 4 to the 4th is 256, and you still set that equal to 3x plus 4. Then we solve for x. So we subtract 4 and then divide by 3, and you get x equals 84. Okay, so if you got that, good job. If you didn't, go back and fix your work. Okay, now let's look at the next one. So you might be a little bit scared about this one, but I promise you it's not going to be that bad. This is the only time where you're going to get ugly numbers just because of e. Okay, so first thing you should have noticed is that we have not natural log of 2x plus 6 equals 2. Okay, so whenever we have natural log, remember the assumed base is e. So what you can do is you can rewrite this as natural log base e of 2x plus 6 equals 2. If you need that step, that's great. If you don't, that's fine as well. I am not expecting you to write that down. So then we can move on to our 3 steps. The 3 steps stay the same. It's just going to be a little bit different when we get to our final answer. So we have step 1, and that's to switch. Now e is going to be our base, and remember that's okay because that's a number. And it's going to have the exponent of 2, and then equals 2x plus 6. Now, normally we would move on to our next step and we would say simplify, but we can't simplify here. Okay? E squared is not a nice number, okay? So we're just going to leave it as e squared, okay? So then we can straight up move on to our next step and solve for x. So I'm going to continue on and subtract 6. So we have e squared minus 6 equals 2x, okay? I just did not simplify e squared because it's not a nice number, and I just moved on. So then I would move on to my last step, and that's to divide by 2. And I would find that x equals e squared minus 6 all over 2. Now, if you are like, what the heck is this? This is what's called calculator ready format. I'm not expecting you to know what this is too much, but I am expecting you to know how to put this into a calculator. Because when we put it into a calculator, we're going to get 0.695. Okay? So I'll show you how to put in a calculator real quick. So you can do this in either in Desmos or a normal calculator. Because I'm doing this on my computer, I'll just do it in normal Desmos. So when you go to Desmos, you're gonna have to go to the keyboard to get E. But no matter what, just type E on your keyboard. And look, Desmos knows that it's 2.71. Okay. Then we had E squared, so we're gonna square it. And then we're gonna subtract 6. Okay. And then we got to highlight this whole thing, okay, and divide by 2, okay? And look at that. We got that number that I just said, 0.695, okay? I rounded to the nearest thousandth, okay? And that's it. So let's move back and continue. So now we have log equals log or exponential equals exponential, okay? So this is the thing where we have to be a little bit more careful because there's a little bit more rules involved. So when we have a log or log, we can only solve and set them equal to each other if they have the same base. Okay. When we have an exponential equals exponential, we have to adjust, and I'll show you what that means. Then we can set the insides or exponents equal to each other and then solve for x. Okay. So looking at our first example, what I'm seeing is I'm focusing on this little number right here. If that little number right there is the same, then I can move on. So what I kind of say is like there's no need for step 1. We can just go ahead and move on because step 2 is set the insides equal to each other. Okay, so now they are equal to each other because they have the same base, and now we're going to solve. So I'm going to subtract 3x from both sides. So I get 19 equals 5x plus 4. Subtract 4 from both sides, and I get 15 equals 5x. divide by 5 to both sides, and I get x equals 3. And that's it. Okay? So if you have the same base, set them equal, and then move on. Let's look at this next one. So this next one is going to be a little bit more creative. No, not creative. It's really the same thing because we have the same base. Okay? So that first step where we have to adjust, there's no need because they are already the same. So we can go ahead and set the exponents equal to each other. So negative x plus 8 equals 2x minus 1. So now we are going to solve. So I'm going to add x to both sides, and I get 8 equals 3x minus 1. I'm going to add 1 to both sides, and I get 9 equals 3x. And then divide by 3 to both sides, and I get x equals 3. And that's it. Now this is where we actually have to get creative. Okay, I misspoke earlier. So this is 3 to the negative x plus 8 equals 27x. If you notice here, okay, they are not the same. Okay, 27 and 3 are not the same. But with 27, it can be rewritten as a number with 3 to some power. Okay, so that is our goal, is if I can get these two big numbers to be the same, I'm good to go. Well, 27 would be the same as 3 to the third power. Okay, so that's how I'm going to rewrite my problem. So that's step 1. We adjusted, and we're now making it 3 to the negative x plus 8 equals 3 to the third power raised to the x power. That is step 1. Now I'm going to simplify this down. We get 3 to the 3x power. So if you remember back in math 2, if you raise a power to a power, they multiply. Okay, so then we can now move on to step 2. Because we have the same base now, we can now set our exponents equal to each other. And then we solve for x. So I'm going to add x to both sides, divide by 4, and I get x equals 2. So this is our last one. With our very last one, I want you guys to pause the video here and see if you can rewrite the big numbers, the bases, such that they match. Okay, so pause the video now and see if you can do it. Right, so this is what you should have gotten. You should have found that 8 could be rewritten as a 2. You could see that 2 to the third power is the same as 8. Okay, so now because these are the same numbers, we can move on. Now before we move on, we need to make sure that we get this 3 multiplied out to each of the 3x and a 1. Okay, in the previous problem, we just had to do 3 times x, but now we have a little bit more to work with. So we are actually working with 2 to the 9x plus 3, and then 2 to the x plus 27. Now we can set them equal to each other, and then solve for x. So take a minute, solve for x. So if you solve for x correctly, you should have gotten x equals 3. Okay. Now this very last note at the bottom says, to check your answer, type equation to Desmos, because you can type in all of these and they will show you the solution to each of these equations. I know I saved the secret for the end. Okay. So all you have to do is type these into Desmos and you can get your solution. But be careful because this will be one of your show your works on your test. Okay, so you will need to show your work for this on your test. So don't just dilly-dally and just find it in Desmos. Okay, I hope you guys have a wonderful day, and I will see you when I come back. Bye-bye.